Assalamu alaikum wa rahmatullah. Welcome everyone to Quality Control, and today we will talk about summary for the control charts, and we will have some extra problems to be solved and explained for you to summarize chapter 6 and 7 control charts, and we see how we deal with the problems of the control chart, how we start reading the questions and how we solve them correctly and answer and have a complete answer for the question. As we said, this is very important chapters, both chapter 6 and 7, and the project will rely on those two chapters heavily, in addition to the coming chapter. The importance of this chapter also is the usability of these tools in real life. It is common to be used, and it is often to be used in both manufacture, production, or a service industry. In this chart here, we have a summary for all the type of control charts. It helps you to identify the type of control chart that you are going to use. So the first decision making about the control chart, the main question you will have is, which control chart should I use? And to answer, you have to identify the type of data. The type of data or measures you have, whether it is continuous or attribute data, variable or attribute. The variable or continuous data, as we talked earlier, is the data are meant for measuring like dimensions, heights, weights, kilograms, and so on. The attribute data is the number of counts, the proportion, those considered to be the attribute data. So first, by looking to the data, we identify whether it is a variable data or attribute, because that will take us to two different branches. If we have a discrete or attribute data, we will go to this branch on the right. If we have a continuous data or a variable data, then we go to the branch on the left. And underneath each branch, we have different control charts. So we have to first identify the type of data, and then we look for the second level for decision making or the decision criteria. Let's start with the variable data or the continuous data, like dimensions, heights, weights, length, time, speed, all that, okay? So let's go with the continuous data and see how is the second level for making the decision criteria or the decision criteria to make selection for the control chart. The second level is the subgroup size. So after we look to the data and identify the type, we look for the subgroup size for this data. If the subgroup size is 1, that is mean individual moving range control chart, which is the X bar MR, or they call it IMR. If we have a sample size greater than 2 and less than 9, then we use the X bar R chart. If the sample size or the subgroup size is greater or than equal to 10, then we use the X bar S chart. You may see some references. They say the 10 subgroup goes also to the X bar. We will stick to our reference here, so we be unified in our solutions. But this is in general to have any small group or subgroup size that the X bar R will be used, especially if it is less than 9. If it is greater than that, then the X bar S chart will be the one selected. So this is how we decide or how we choose the appropriate control chart for our readings. The second type of data, which is the discrete or the attribute data like counts, proportions, those are followed a different criteria. The criteria is whether the data or the measures or for defects or defectives. And you have to pay attention to the difference between those two, non-conforming and non-conformities. Those are very important to identify before you start look for the chart. We have to identify whether it is non-conforming or non-conformities or defective or defects. What is the defects? Is the number of defects found in the sample, and the defective are the units that are no more can be used, so it is like a waste. If this is found, that's mean that unit will not be able to be refixed again, whereas the defects, there is a chance to correct it and return it, even though the process will consume money and time, but it will be corrected. Defective, those are damaged or waste items in the patch. As we said, when we talked about the P-chart and the NP that follow the defective, the decision criteria here, it becomes to the sample size. Now we have again this third level of the decision criteria, which is the sample size. If the sample size is variable, that means it's changed between a patch to another, then we select the P-chart. If the sample size, it is constant, then we use the NP chart. Even though the P-chart also works for constant and variable, but the NP chart, it works only for the constant. So you may face a question that has a constant data and ask you to use a P-chart. So in that case, it is correct because as we explained, the P-chart works for both variable and constant. So we can add here in order so the students also know that constant and variable. Or the last type of charts or type of chart, which is the defects chart. Those where you have defects like scratches, some dimension or excessive in the material, so it can be reduced. In this case, we use either one of those two, which is the C chart or the U chart. The idea of the attribute data, the good idea or the good thing or the advantage about those two charts is the simplicity to be designed. It is very simple to design them, and it is easy to also detect the out of control or detect falses in those two charts because they work as a single chart, like for developing U chart or C chart or even the P or the NP, you are developing a single chart, whereas here in this side, you are developing two charts underneath each category. So this is one of the advantage, and we said one of the disadvantage that it require large amount of sample size. So the U chart and the C chart, the decision criteria is if the sample size is constant, then we use the C chart. If the sample size is variable, then we use the U chart. So this is how we decide about the control charts, and we will start now solving problems, and I will need from you to collaborate with me in the chat box when I ask the question to answer what is the steps needed or what is the right formula needed. Before we start, I would like from you to take a screenshot for the slides that I will present now. Have your Minitab ready or your Excel ready. Have a piece of paper, calculator, and pen with you. We will need all that now while we are working on the examples. For questions here, do U chart could be used for both variable and constant. In the cases of some references, they may use it, but it is not common really to use. That's why we don't consider it as for the P chart. It is very common to have it because of the similarity even in the formula between the NP and the P. They are almost the same formula. But the U chart, I don't say it's 100%, no, but it is not really favorite to use it. Always when you have a variable, it would be better only to use the U. If you have a constant, only to use the C, okay? To answer that question, if the U chart also can be used for variable and constant. Now, please take a screenshot for those constants that we are going to need them now while we are going to solve problems for the control chart. This is the first one. I will zoom it in. Take a picture for this table and this one here. Take a picture for that one also, because we will use those constants now when we develop the control charts. Now let's go back to our slides and we start with the first problem and try to solve it together here. There is a question also about the sample size and the subgroup size. The difference is about not the sample size and the subgroup size, because here it meant the same. The difference is between and the sample size. Number of samples, this is an example here, we have it. How many samples we have, and what is the sample size here? This is a question I directed to you, and you may answer it and will answer also your question. Oh, okay, there is a required here to go to the tables. Again, I will go for once here. Please take a shot from your phone or a screenshot. So this is once. Here is the table again. Please take a screenshot for this one. The second one. Okay. So let's go back to our problem. Now, before we talk about the sample size and the number of samples, looking to this data, there is no information in the question says what is the type of control chart. Imagine if you have a problem like that, what type of data? We start with the first decision criteria. What is the type of data here we have? Is it variable or attribute data? Correct. Excellent. This is a variable data, and it's clearly from the numbers here. The readings, all continuous data is not attribute. So this will help you now to focus on the chapter 6 control charts and eliminate chapter 7. So when I have such data, I will do the same. I will start with this major criteria, because this will direct me to a different type of control charts. Now, the second criteria in the variable control chart was the sample size, or the sample or the subgroup size. Now, here is the question. What is the sample size here in this question or in this data? Correct. Excellent. It is 4. So the subgroup size or the sample size is 4. How many samples we have? We have 8 samples, as we can see in the column here. The column says sample, and these are the number of samples. Each sample has 4 readings. So let's say he is starting to take samples at 8 o'clock in the morning. When he go at 8, he will pick 4 measures regarding if it's products or service. Then he goes at 10 a.m. This is going to be sample 2, and he will take another 4 readings for 4 different products or service transactions, and so on. So this is the number of samples, and this is the sample size. Sample size is 4, and the number of samples 8. The question asks, what is the best control chart should be used for this given data? Excellent, Uthman. We have an answer that is X bar R. Why? Because if we look to that decision tree that we had, it says if we have a sample size greater than 2 and less than 9, we select the X bar R control chart. What is the, when it says calculate the control chart parameters, this is very important. When it says show your calculations, you have to show it manually. It doesn't mean that you go and draw the control chart on the Minitab or any software and you just upload it. Grading will be based on your manual calculations for the control chart parameters. When we talk about the parameters, that in the formula for the control chart, which is the center line, standard deviation, mean, bar, X bar or R bar, the upper control limits, lower control limits. The variables that in the formula, those are the parameters, and they need to be calculated manually, because here you are drawing, you are constructing the lines and the boundaries for the control chart. Then you draw the measures on the control chart. So the third question here says, construct the control chart and make your recommendation about the chart. This question where you upload your control chart that you did develop it on the Minitab or any software application, or even if you want to use your hand, you don't have a software, or you would like to draw it your hand, this is up to you, but you have to be, it will consume time, especially if you have samples like that, it will may consume your time, because especially like X bar R, it will require 2 control charts, one for X bar and one for the R bar. Or the X bar and the R chart. Now, those 3 questions, as now explained, each one of them answered differently. So don't jump to the control chart and upload it and you think that you already answered the question, or you show me the upper control, lower control, center line, and you said those are the only parameters. The parameters are all the parameters in the formula. Go to the formula on chapter 6, and that is the parameters, and I will start typing those parameters, for example, for just show you how they will look like here. So let's start with the okay, I will use the space here. So the X bar equal to the readings divided, the sum of readings divided by 4 for every sample. So there will be a column here says X bar, and the first one will be 18.9, and then the second one, I will show you all that in the file, but this is just to show you how you answer the question. So the 18 For those sample number 1, this is the average and this is the X bar. The R, it has to be based on the range. And how we calculate the range? The range is the difference between the highest and lowest. The lowest here is 16.5, and the highest is the 21.2. So the difference between them is 4.7. So you write for the first reading 4.7. You continue those two columns until you get all the R for all the samples and the X bar for all the samples. After you find them, then you calculate the X double bar and the X bar, the R bar. The X double bar is the average of all these readings, the average of all the X bars. And the R bar is the average of all the reading, all the ranges. So now let's go back to the formula for the upper and lower control. The upper control is for the X bar chart, for X bar chart equal the upper control limits equal to, and it is in the slides earlier that is being posted. It is X. I don't have double bar here, so I will use, or I can write it double bar plus, we can say that it is the standard deviation, or which is the A2 times R bar. And the lower control will be X double bar minus A2 times the R bar. All the constant found from the tables that we showed earlier. If we are looking for the constant A2, who took those pictures for that table, what is the constant for A2 will be when we have a sample size 4. For the A2, we will have the value not 1.02, no, it is 0.796. A2, it is 0.729 or 96, depend on the first page or the second page, both of them are correct. So this is the value of the A2. The R bar, after you calculate the range, which is the difference between the highest reading and the lowest reading, you draw or you continue with this column here and you get all the R's, all the ranges, and then the R bar will be the average of all those ranges. You will see that all in a few, just to show you here how we proceed. For the lower control limit, you will use the same formula, but instead of the plus here, you will use, instead of the plus here, you will use the minus. For the R bar chart, when we develop the control limits, the upper control limits, let's say, it is equal to what? D4 times R bar. From the table, what is the D4 value at the sample size 4? It is 2.282. So you multiply this 2.2 with the average of all the ranges to get the upper control limits for the R chart. The parameters, when we talked about the parameters in the second question here, that means you have to find the X double bar and show your calculation, how you calculate it. You show the A2 from the table as a constant value. You show the R bar, how you calculate it, and the upper control, how you calculate it. The center line is the X double bar. So you have to show here your calculations for all the X bars first before you show the X double bar, how it's been calculated. This is how the complete answer will be considered for this question. I will share with you now the answers so you can write them down and verify later when you practice this question your answer with. So let's share. So this is how you have to show the constants, how it's been calculated, the R bar, how it is calculated, the X double bar. Did you see here the X bar? That was calculated from the previous. The X bar, when I calculated on the slide, it was, sorry, the range. So the X bar is the 18, and the range is 4.7. Here there is a mistake. I will show it to you on the software now, how it is calculated. So let's go here and see how data. This is all the readings for the 8 samples. Reading 1, 2, 3, 4 for the samples 1 until 8. To calculate the X bar, which is the average, you can go on Excel, you can calculate it on the calculator, show what is the formula of the average, which is the sum divided by the number of readings. On the mini tab, in order to calculate this column, you can go to calculator and press here on the calculator, and you can put the average, and it will calculate the average for you, but it will give you the average of all these readings. In order to have a column like that for every reading, an average, then we have to do like that. Go to row statistics, and then you select all the readings, X1, X2, X3, X4, and you store the result on, you have to name the cell first, so we have to call it here example. Okay, so go back, calculator, sorry, the raw statistics. You have to select all the readings that you would like to have the average. Then where you would like to store the result, I will store the result in the example. And then you can select the statistic you would like to have: mean, range, median, variance, standard deviation. So if we select the mean, it will calculate the mean for every row. Since we have used the row statistic, that's mean. He will do the statistic for every row. If you choose the column, it will do the statistic for every column. This is the X bar for all the 4 measures. What about the range? As we did for the example here, we will do the range. So we go to the row, and we select the range instead of the mean, and the same data and the same place, and then we press OK, and then it will show us the results for the range. So this column, you have to show your calculations, how you calculated, how you calculated the range. It is the difference between the largest reading in the row, which is the 21, minus the lowest reading, which is the 16.5. In the second samples, we have the highest 21 and the lowest is 17. So you subtract them to get the range. The average, basically, you get sum of them divided by 4. What about the X double bar? The X double bar is the center line for the X bar chart. So how we calculate this X double bar? You can just go here. I can show you in another cell. The calculator, you have different ways to do it, but I can show you here in different functions, so you can also try it at home and use all these functions later to know how to use them. First, you store the results where you select where you would like to store the results. Let's say that I'm going to store it here in the X double bar. Okay, and the expression, you have a list of functions here, and you can select from them. The statistics are the most common that we use here in this course, but also the others also common to be used, but those are the most frequent, I mean here. Here you select the mean because you would like to have the mean of the X bar readings. And when you press select here, it will show you the expression and it is highlighted in blue. Instead of having number, you select the data where you would like to calculate your mean. In our case, the readings here in the X bar, which is C5, where is the average of every sample we have. So we would like to have the average of all these averages. So we double click on the X bar and then we press OK. Okay. Because it is calculated here, so it is already, I will try maybe to here again, but because it was calculated, I will do it here. So I will store the data in C instead of the, I just call it XDB for an example. X double bar, everything the same, okay. So yes, it is here again, because it was calculated here, so didn't do it again, but this is, here is the X double bar. The R bar is the same as we did for this case. So we go to calculator and we choose the same XDB, but instead of the mean for the X bar, we will go for the range. We want now the R bar. The R bar is the average of all the ranges. So we go to C6. We select C6 and then we press OK, and that is the R bar. Now we calculated the center line, the parameters first for the main parameters for the control chart, but we still have to calculate the upper control limits and the lower control limits. To calculate the upper control limits and the lower control limits, you need those two values here in C7 and C8 first in order to calculate them. And then you use the constant in the table and the formula from the slides in the chapters to calculate the upper control and the lower control for every chart. You have to show the upper control, lower control for the X bar and the center line for the X bar, the center line for the, which is the X double bar, and the center line for the R chart is the R bar. to calculate the upper control, lower control for each one of them, you go and follow the formulas that we have just explained, and we already explained it earlier in the chapters. You need the constant in order to do that. The third question was to draw or construct the control chart. In this case, you go to the stat, as we did earlier, variable, and then you go select the X bar R. You select the observation in one row, because the observation in one row is not in one column encoded like the example we had earlier. It is in one row, and then after you select the data from all the measures from C1 to C4, then you select OK, and it will show you the control charts. This is the X double bar. It has to match here the value 20. The R bar here, the center line for the R chart, it has to match this value. And the upper control and lower control, if you calculate them, it has to match, or at least the fractions, it could be different, like the decimal numbers, it could be different because of the usage of the tables, a constant, but it has to be similar in terms of the integer number or the main number. What else? Yes, we cannot consider showing the upper control limits and lower control limits value as you calculated the control limits. Again, I'm emphasizing on this, and this is how you will be graded. You have to show in the formula how you calculate the upper control limits and the lower control limits, as I showed you just now on the slide and on the screen when I showed you the answer. You have to show step by step how you calculate on hand, and not just showing the value of the upper control and the lower control, okay? And then you can match them with the chart. You may see some differences if you do the hand calculation compared to the software, and this is where we can also verify that how is the answer. It can be different if you use the calculations and the software, because the software constant, it may have slight different changes or differences than the one you used. This is how you construct the chart. Now, the question contains a very important requirement, which is, what is your suggestion? Now, if you have a control chart like that, what will be your suggestion? Now, as you can notice, on sample number 6, there is out of control point. So your suggestion will be eliminate this point and investigate about what is the special cause that caused this out of control. So we have to investigate about the cause and eliminate this point and recalculate the control limits and draw the control chart again. Because when you eliminate this point, sample number 6, the parameters will be different. Imagine here, or look at here, we have the X bar and the range column. Sample 6 will be eliminated. So the value of the X double bar and the R bar will be affected, and it will be changed. So you have to recalculate the parameters again and draw the chart again and see what happened. Will the process go in control again and everything look normal, or there is out of control point that appear on the charts again? If everything normal, then you can continue with those limits. If there is another out of control point, then you have to do the same until you get the process in control. Do this in the second time, and then you appears many points out of control, then you can say that those control limits are not suitable for this process, and the process has significant out of control points and need further investigation. Because it is normal to have 1 or 2 points out of control, and sometimes when we reconstruct the control chart, we may face another out of control, but the process, the remaining points remain the same. But if showed to be out of control in the second trial, then the process needs to be investigated more, and we cannot continue with those control limits. So this will be your recommendation. And it is very important to understand the steps, because it is what you have to do when you face a question like that. Now, let's go back to our slide and continue with the second problem. Okay, this is the second problem we have today, which is the viscosity of a material measured and given this table below. Again, no clue what control chart needed. It didn't say what is the type of control chart we will use. So what is the first thing we have to do? We have to identify the type of control chart. We have to identify the type of the control chart. And in order to do that, we have to identify the type of data. What is the type of data here? What is the viscosity? The viscosity is Luzuja. And to measure the viscosity, you have to measure it is not counts. They have their own devices to measure this viscosity. So that means this data is variable. It is variable distribution and our variable data, and it needs to be handled based on the control charts for the variables. Then we go to the second criteria, or the decision criteria. What is the sample size? Did he mention here the sample size? He said test 1, test 2, test 3. Didn't say any sample size. Okay, now what would be the guess for this control chart? In the variable data, we have 3 types of control charts. All of them are relying or based on the subgroup, not the number of samples, the subgroup size. Here we have only samples. We don't have subgroups. So what are we going to do? Okay, excellent, Uthman. We have a control chart for individual readings that is not requiring sample size under the control charts for variables, and it's called IRM, which is individual moving, IMR, which is individual moving range, or the X bar MR, or the X bar moving range chart. They call it both the same. So here is again, didn't require what is the control chart needed. From looking to the data and understanding what is those measures, what is the type of data. But here in this question says something new. Says, does the measured data follow a normal distribution? Okay, this is new. And why do you think he's asking this question? Because in the variable control chart, we assume that most of the data that need to be following a normal distribution, and also this is testing the normality of the data, is not following other distributions. So how we do the make or test the distribution? We have the p-test, and we can conduct it and show the plot for the normality, and then we can tell if it's the data, it is normal or if it is not. And to do that, you can recall the chapter that we had in chapter 2, I believe, when we had normality test, and then you can do the normality test, which we will do also today. The plot, whether the data is normal or no, and check the p-value if it is greater than the 0.05 or no. What about the second question? The second question says, what is the appropriate control chart for the given data? And calculate the chart parameters and show your calculations. Again, we have identified the appropriate control chart, which is the IMR. And to show the calculations, we have to follow what we said earlier. We have to follow the formulas and show all the calculations needed for that X bar moving range or the X bar individual moving range. In the individual moving range, we have some constant also needed to be calculated, like E2 and D4 and D3. For the X bar chart, we use E2, and for the moving range chart, we will use D4 and D3. So we have to go to the constant and look in the table. When you look to the table for constants for individual moving range, you start or you use the first one. You assume that this is the minimum number of sample is given in the table and you select them. So in our case, we will need the E2 for the X bar chart, and the E2 value equal to 2.660. And for the MR chart, we will need D4 and D3. D4 for the upper control and D3 for the lower control of the MR chart. D3 equal to 0. It is common to have the lower control 0 in the moving range, and the D4 will be equal to 3.267. Those constants, you are going to use them to control parameters in the for the X bar chart, X bar moving range. There is a question: what is a normal distribution? Is it going to affect the IMR? It will affect it, because the normality assumption, it is for all the variable control chart, not like the attribute. But in those cases, you can use the center limit theory and you put the data in normal again. It is rare to do that. It is rare to find that, because usually continuous measures gives you normal distribution, or distribution can be normalized using the center limit theory. But we will not ask this to use the center limit theory. You can just know that how we deal with it. But testing the normality, it is part of the previous chapters, and you may see something like that in a question. For example, the final, which include all the chapters, so it can have questions from different chapters related to the same data, and that's why I pulled this question. But doesn't mean that you will have something not normal, ask you to do the chart, because it's going to contradict with the requirement in B and C. But if you face something like that, you can either continue the control chart. It will be recommended to normalize it first using the center limit theory, and then we use the data for the control chart. So now let's go back to the upper and lower control limits for this chart, and how we can calculate those using the formulas we have covered in chapter 6. the upper control limits equal to x bar plus the 3 times MR bar divided by D2, which is both, all of those equal the constant E2. You can use either. If you go to that slide for that chapter, you see that we demonstrate formulas. Both of them gives you the same answer. And the value for this one, you have to show it on hands. I'm showing this here step by step to show you how the answer is needed. This is how you have to show it on the answering or showing the calculation. I believe this will not be enough here. I hope I can move this one here. Okay, so we can continue. Writing here, it is a little difficult, so spare with me, please. 0.47. And that is equal to 99.68. And this is the X bar upper control limits. I will show you the upper control limit for the MR chart, which is equal D4 times MR bar, which equals to 3.267, the D4, as we found it from the table, times the 11.47. And that is equal to 57.47. But here, what are we missing, or how we found the value of the MR bar, and also the X bar. So we will go back to the data here. The data, you have to find the X bar by having the average of all these readings in order to find the X bar, and you have to calculate it, and it is equal to the sum of readings divided by the number, which is here we have it 20, and that is equal to the 69.17. For the MR, the moving range, you have to find the moving range for every 2 readings, and then you find the MR bar. The MR1 is equal to the difference between the first 2 readings, and you have to use the absolute value. So the moving range, you have to use the absolute. You don't use the minus value if it appears. So we subtract the 27.85 minus 28.38, and that is equal to calculate it for me, and that will be the the moving range for the MR1. For MR, that will equal 53. You have to use the absolute value, so if there is a minus, you have value and make it 53 instead of minus 53. MR2 will equal to the subtraction of reading number 3 and number 2, and that is equal to 27.85, and you find the answer, and so on. You continue until the last reading. The first reading, which is a moving range, you cannot subtract it because this is the first one. You have nothing previous than that one. So we start always one step ahead and calculate the MR. Now we will share the screen and we show you how you do that also in the software application, and how you also construct the control chart on the software. So let's go and share the screen. Okay. This is the data, the viscosity data, and this is the column of the moving range that I was explaining to you. So this 53 was basically the subtraction between the first reading and the second. The 273 was the subtraction between the second reading and the third reading. So always we have nothing here on the moving range column. How we calculate this on the mini tab in the Excel, I believe it is maybe even easier, because you do equal and then you search for the functions and you press the functions. Here is not different than there, so we can use example because we need to identify cell first, and then we go to the calculator here, and we have to use the, hold on, let me just give me a second. We have to store the data in new cell, which is the C5 here, and the expression that we are going to use, it is the ABS, which is the absolute, because if you just do the differences, it will show you values in minus, and when you do the average, it will definitely make your average wrong. So you have to use the ABS first in order to find the positive value for the subtractions. Now here we have to go to something called the column functions, and then we select the difference because we want the difference between the readings, and you can see the function, it is already here mentioned, the number and the lag. And the lag means the shift between, or how many times he has to skip between the cells. And when you press, it will show you the number is highlighted in blue, as well as the lag, it has to be identified as a number. And in this case, we select C2, which is the viscosity data, and the lag. For me, I prefer the Excel in doing this function, but this is to show you how you can do all the things here in the tab. You press 1 because you want to move one cell at a time to subtract between the cells, and then you close the bracket and you press OK, and then it will subtract each reading one cell ahead, one cell previously. Each reading one cell previously, each reading and one cell previously, and that's what the lag 1. This is how we calculate the moving range. To calculate the average, I think we already explained that, but show it here, which is the MR bar of MR. Pardon me. Okay. As we did earlier, we use the calculator and we store the value here on C6, and we select from the statistics mean and select, and then we select the data of the MR, and that will be the MR bar. MR bar. This will be the value 148.158. The first question asked about the normality. We didn't forget about that. So how we do the normality, this is how the normality test look like. You can tell that the data almost is on the normal line or the probability plot line. So consider to be visual, but also statistically, you look to the p-value if it is greater than 0.05, because we are using a confidence of 95 test, then we can say the data is normal. If it is less than 0.05, then we cannot say it is normal. To do this test, basically, I think we explained that earlier, but to go to basic statistics, and you go to normality test, and then you select the data and you press OK, and it will show you this figure that here. Again, you can download the figures, print them, save them, or you can change even the titles. Okay. Now, to draw the control chart for the individual moving range, this is how it look like, and you have to match here the average moving MR bar. It is the center line for the moving range control chart. So those two values has to be matched. And the X bar, it is easy to find it. Average of X, or the viscosity readings. Again, you go to the calculator, you store the data here, and you select the mean. Here, select it 2 times. So select the mean, and you go to the reading, the viscosity, and then you press OK. And that number also, again, it has to be matching the center line of the X. On the showing the calculation, you have to show them manually how you calculated them using the formula. You don't show the final answer. I'm emphasizing this for the 3rd time. You don't show the final answers, upper lower control limits, as you like copy them from the control chart without showing the calculations, because the calculations in hand, it is slightly different in the values compared to the chart. So it will not be graded completely, your question, if it's asking you to show the calculation and didn't show on hand how you calculated them, because it's used in the software, slightly different values in terms of the decimals compared to the tables, and you have to show both how you calculated them in hand and on the chart. In this case, we have a control chart, looks in control, so no changes, and everything looks fine. So now we will move to a 3rd problem and show you a different problem that deal with a different control chart, how we deal with it. And remember the steps. First, we look to the data and see what is the type of data we have. Here is the example we have. The example says we have the data below for non-conforming builds in a lot size 2,500 units. And what is the control chart needed here, or what is the control chart that is suitable for this data? What do you think? First, we start with the data. What is the type of data here? Okay, it is attribute data. Excellent. Yes, it is attribute data, and that is a good lead. So it will take us to the 2nd decision criteria. If we have attribute data, then we have to look for what? It is the defects or defectives? It is defectives. Excellent, Abdelaziz. Why? Because it says non-conforming. Pay attention. It is slightly different than non-conformities. It confuses students, so pay attention. It says non-conforming builds. That means those builds are waste. You cannot. It's going to for waste. They cannot use them or fix them again. Okay. So those units appeared in every time they have a lot of 2,500 units. So this first sample or the first lot, which contain of 2,500, they have 230 builds non-conforming. 2,500 units, they have 435 non-conforming. The third 2,051 defective units. Okay, so defectives, non-conforming, both of them the same. The questions, read the questions always carefully in the control charts. The control or the quality control about precise, about readings carefully, about read between the lines and read the data carefully. You are a quality inspector, you have to have this skill. So when you read the questions here, always read them carefully and answer them precisely as it is required. It says, what is the appropriate control chart? You have all identified it is defective. So what is the type of control chart we are going to use if it's defective? What is the last decision criteria? It is P chart or the NP chart? NP chart. Okay. And when we go back to our decision tree, both charts actually can be used for here because it is constant and the lot is given here and the sample size, it was not given. So we have the P chart is more suitable to be used since we don't have the need to use the NP chart. The P chart is basically needs from you a step before we can go and calculate it. This data is not ready for the P chart immediately. Why? Because these are number of non-conforming. So if you have used the it is constant here. In this case, it is constant. If you use the NP, there is nothing wrong about that, but usually it will show you that a question have you a sample size in addition to the lot size or the number of lot size. But in the case if you don't have variables like every lot here, for example, has a different size. Here, for example, it has 2,000, here 2,500, here 1,000. So the lot size is different. Then definitely the P chart is the only chart to use. But here, in this case, there is no harm to use the NP chart also, since it is constant lot size for the 2,500 for every lot. The reason is I'm showing you the P chart now, or even if you have used the NP chart, it will not making that much of difference in terms of the decisions. It will be similar to each other, and I will show you this now. I'm just looking to the time. Hopefully that we can finish. We still have another problem in addition to this one. So I hope we can do that all today. Let's continue and try to show you here. Okay. Just give me a few minutes. Just freeze. Okay, so let's go back to the P chart first, and then we do the NP. I think maybe we will not be able to continue this because it will take time and we have another problem. So what we will do is we will continue in the second or in our coming meeting. What we can do now, it would be maybe better to use this time. Now you already have this question. Please take this question, screenshot, and take a picture of that question. We will continue with this question in the coming meeting on the next week. So please take a picture of that question and on the coming question, this one. Take a picture for both of them. Please, before the next meeting, practice those two questions and bring your solutions to match them with ours here. As I told you, in this question, I would prefer to use the P chart, but if you use the NP, it will not harm. The P chart, it is more accurate because it uses the proportion instead of the numbers. So it is linking the lot size. But in the case like this one here, I would show you both of them, and both of them will give you the same decision at the end. So it will not affect the decision at the end about the data. For the third one, or the last one, I will not say what is the control chart is needed, and also I will leave this for you to try it and bring it on the next meeting so we can discuss the answers. So this is for all now, and we will continue in the next meeting, and we will do now the attendance for the coming or the remaining few minutes.